Bernoulli trials, also called binomial distribution, example 3. Given that 10% of apples are bad, find the probability that in a box containing 6 apples that there are either no bad apple, just one bad apple, or at least one bad apple. We're going to use the binomial distribution formula in the log tables to solve each of these questions. Starting off, we want to work out what the probability of success, P, and the probability of failure, Q, are. I'm going to define P success as there being a bad apple. So the probability that there is a bad apple is exactly 10% because there's 1 in 10 chance. And Q, the probability that an apple selected is not bad or is a good apple, is 90% or 0.9. Now let's look at the questions that we're doing here. We know that there's 6 apples, so n, the number of trials, is 6. We're going to use that in the formula each time. So question 1, we're working out the probability that there's no bad apple. So this means if there's no bad apple, means that there's no success in the 6 trials, only failure. It means what we're getting is a good apple, a good apple, a good apple. We're getting it 6 times in a row. So we wouldn't have to use the formula to do this. We could just use the multiplication rule that we're going to multiply the probability that is good, that's 0.9, by itself 6 times. So it's 0.9 to the power of 6. You get the same answer if you use the binomial formula, but there's no reason. And here we see that's almost 0.53 rounded 2 decimal places. So 0.53 or 53% of the time we'd expect that you get no bad apple, that they're all good. The next question is the probability that there's exactly 1 bad apple. Now we will use the binomial formula for this, the binomial distribution formula. So we know that the number of successes is 1, there's 1 bad, the number of trials is 6. So R is 1, N is 6. So we have 6C1, P, which is 0.1, that happens once, so that's to the power of 1. And failure, 0.9, happens 5 times, so that's to the power of 5. So we evaluate this using our calculator then. 6C1 multiplied by 0.1 multiplied by 0.9 to the power of 5. And this is approximately 35% or 0.35 to 2 decimal places. In the last part, we're asked to figure out the probability that there's at least 1 bad apple. There are many options for this. It could be 1 bad apple, 2 bad apples, 3 bad apples, 4, 5, 6 bad apples. So the quicker way, rather than figuring out all of these and adding them together, would be to figure out the opposite. Figure out the probability that they're all good and subtract that from 1, because they're either all good or at least one of them is bad. So the probability at least one is bad is 1 minus the probability that they're all good. Now we've actually figured this out. In the first part of the question, we figured out the answer to that. It's a 53% chance that they're all good. Therefore, it must be a 47% chance there's at least 1 bad, that they're not all good. So 47% or 0.47 is the answer.